Hello, in this video I will demonstrate how to work out a problem using the F-test. The F-test is used to compare differences between variances and standard deviations. We begin with the following example. A researcher is testing the difference in standard deviations between two final exam results for two classes that she teaches. The first class is Managerial Accounting 1. The second class is Financial Accounting 1. She believes that there is a difference in standard deviations between the final exam scores of both classes. Test her claim using alpha equal to 0.10. Data is supplied for the Managerial Accounting class and for the Financial Accounting class. These are the final exam scores. Step 1, we should calculate the standard deviation for each data set, and we always want to make sure that the larger standard deviation has subscript 1. Let's look at Excel. So Excel has a built-in function that allows us to calculate standard deviations. And that function is called STDEVA. I use it, I select the array of numbers, and the sample standard deviation is computed. I'll round it to 2 decimals. Thus, for the Managerial Accounting course, the standard deviation is 11.76. Let's count the number of values using Excel. There's 13. And then we can take advantage of some unique functionality of Excel to rapidly compute the standard deviation for the Financial Accounting class and the sample size. It's also 13. And of course 11.76 is greater than 8.58. Thus we label this data with subscript 1, this data with subscript 2. Our next step is we write down the claim using population variances. So in this, the claim is that there's a difference. So the claim is that the two variances are different, are not equal, and H naught is the variances are equal. Next, we compute the degrees of freedom of the numerator and degrees of freedom of the denominator. So the degrees of freedom of the numerator is n sub 1 minus 1. 13 minus 1 is 12. And it so happens in this case that the degrees of freedom of the denominator, n sub 2 minus 1, is also 13 minus 1, which is 12. Now our next step is we will divide alpha by 2, because for the book we use, we are not provided with the left critical values. So we have to focus on the right tail. Thus, the right tail has an area that's equal to half of alpha. So the alpha we use is half of 0.10, which is 0.05. That's going to be this area. We ignore the left tail. Now we look up the critical value in table H, and of course we draw the F distribution. And as I mentioned before, we focus on the right side. So looking up the critical value in table H, we search first for alpha. Remember, table H has several alphas listed. We look across for 12. We go down 12 and we see that it is 2.69. So the critical value is 2.69. Next, we compute the test point. The test point is F equal to sample standard deviation 1 squared divided by sample standard deviation 2 squared, That's 11.76 squared divided by 8.58 squared, which is 1.87. That value will fall in the non-critical region. So our decision is to not reject H naught. And we summarize by stating that there is not enough evidence to support the claim. Thanks for watching the video.